Hello, my name is Mohammad Moise and I will be presenting you the presentation on the research paper Semantic Preference Based Personalized Recommendation on Heterogeneous Information Network. This is the table content that I will be presenting you in the presentation. Introduction. With the explosive development of internet and big data, users now have access to large amount of optional information when shopping. To facilitate selecting an appropriate item, the recommendation system emerged and now widely used. These methods utilize historical information concerning interaction between user and items recommended by similar users. However, in the real world, users usually interact with only a limited number of items. In the face of such cold start and sparse feedback, data problems, collaborative filtering methods often do not work well. These are the companies that uses the recommendation system: Flipkart, Amazon, Best Buy, and eBay. First, I introduce binary user feedback and then introduce the concept of heterogeneous information network and meta parts. Finally, we will discuss the problem definition. We use similar definition of binary user feedback to that of the definition of user implicit feedback. The user rating matrix R is constructed by the user rating of items in the user feedback matrix. The value 1 means that user have rated the items and 0 means user did not rate the item. The heterogeneous information network is an abstraction of real world and it focuses on entities and relation between the entities. We use a network schema to present the nodes and relation types in a heterogeneous information network. Example of metapart defined in a network schema in figure 1. You can see that user, movie, actor, actor, movie genre and path and so on. The meta path can be semantically explanatory, and when two nodes are connected via different paths, they hold different semantic information. In this paper, we choose two meta paths with explicit semantic information. For example, in this figure 2, semantic information expressed by the user movie actor path is the actor U that watched a movie has the actor A starred in. In our proposed model, on the other hand, we use a semantic information expressed by these metapaths to provide an interpretation of users' feedback behavior. On the other hand, we calculate the similarity of user based on metapaths. Problem definition. In a heterogeneous information network, the metapath provides a variety of hierarchical semantic information that enables representation of user data and item data of recommendation system and complex relationships between the system and the complex relationship between them to represent in an information network at the same time. Therefore, based on heterogeneous information network concept, we define the recommendation problem studied in this paper as follows. Given a heterogeneous information network and user feedback, we aim to build a personalized recommendation model for user based on historical user feedback to predict the rating of user for the unobserved interactions. We introduce a similar method based on a combination of metapath and user feedback to analyze user potential preferences for items. We define a recommendation function based on users' potential preferences. Finally, we introduce a personalized recommendation model. These are the methods that I will discuss. Metapath. By combining the semantic information expressed by metapath, we can closely approximate the reason why a user might be interested in an item. Sometimes a user chooses to watch a movie not because of the actor or the director based on their preferences, but because the movie received a high rating score. We can find users similar to the target user under a given metapath. Then we can predict the target user score on item based on rating score of similar user. We define the score prediction method of this formula. We combine global recommendation model. We combine the rating for we combine the rating from different paths and consider different semantic relation may have different level of importance. Define a global recommendation model. A global recommendation model assumes that the weight of all user preferences are the same. In fact, each user has its own specific preferences. The global recommendation model cannot achieve personalized recommendation. So, based on the different distribution of each user preference, we construct different model based on personalized weightage. We calculate user similarity based on interaction between a user and an item, which shows similar users have similar preferences. To illustrate the performance of the proposed algorithm, we choose two real-world datasets to perform the experimental research. The first dataset was Douban database. The Douban is one of the most famous community websites in China that includes user, movie, and rating-related data. The dataset includes the second dataset is the Yelp dataset. That dataset includes the data of users and business as well as the rating ranging from 1 to 5, reviews and business information such as categories and city locations. These are the experiment result analysis. For the first two datasets of Douban and Yelp, we applied different training set ratios for 20%, 40%, 60%, and 80% to observe the effect that data sparseness has on the above method. PMF is basic matrix factorization method that uses a user item matrix for recommendation. BMF is an improved collaborative filtering recommendation based on PMF. From the table we can observe that the performance of BMF is better than the performance of PMF under all conditions. The SAMREC method is based on a weighted HIN. It combines both relation features from the heterogeneous information network and user item score ratings. The performance of SPR Global and SPR Personal are much better than PMF and PMF under all conditions. Our proposed global recommendation model SPR Global combines heterogeneous information network rating value to achieve better performance on both datasets compared to the performance of PMF and DMF. Compared with the global recommendation model, the personalized recommendation model SPR Personal yield better performance in all the other conditions. Conclusion. Okay, in this paper we studied personalized recommendations based on user preferences point in a heterogeneous information network. We implemented a similar measure under different relations, and on the basis we need recommendation model at both global and individual levels. A personalized model based on user potential preferences was used to solve the problem of sparse data available and individual users. The method demonstrates a more accurate use of user preferences point. The proposed method achieved a better results. That's the end of this presentation. Thank you for listening. Bye.